Hello everyone, this is Mukundan Raghavan, and in this video we are going to continue with data frames. In previous videos we have seen about RDD, which is low level API for data, and in this video we will discuss about data frames. We will start with why use data frames instead of RDDs. As we discussed already, data frame provide a higher level of tabular API rather low level API like RDD. And also, it has several advantages over RDD. Some of them are easier to express SQL kind of operations. And also, unlike RDD, it will have the schema. Along with that, some internal parameters, such as it will improve the performance by using the Catalyst Optimizer and Tungsten engine. Even though it is not directly exposed to us, it will help in higher performance boost. In general, RDDs do not optimize your code. Whatever the transformation you write, it will execute as it is. Whereas data frames will optimize. For example, it will improve the logical plan, the best execution strategy for your transformations. And also, Tungsten engine, it will improve the memory usage and CPU efficiency so that data frames are more faster than the RDDs. Along with that, RDD pipeline, if you write the transformation cannot reorder or optimize. In data frame, it will do the optimization automatically. For example, it will filter the data so that you will have the reduced data volume to have the transformation. And also, it will remove the unnecessary columns so that your performance will be boosted. Like this, several optimization will be happening in the data frame, whereas in RDD, it will not happen. So that's the reason we have to go with data frames. However, on the other side, if your data is not structured or it is unstructured data, then we will go for the RDD. So if you see comparison between RDD and data frame, we have so many places where data frame has the upper hand. Now we will get into the data frames. The first and foremost thing, we will create the Spark session and Spark context. As usual, whatever we have seen in the previous video, we are doing everything in local, so we will have some extra setup. Now, after doing this Spark session and Spark context, we will be directly getting into the data creation, basically data frame creation. Now here you can see, since it's a demo session, we will create the data by using the tuples of data. Every tuple has 3 columns. The first one is ID, second one is name, and third one is marks. And once we have this data structure, like a list of tuples in Python, then we will pass this to the spark.createDataFrame. CreateDataFrame is the very simple method where you will pass your data and also you will pass the list of headers or the fields name. It is not only way that you can create the data frame. There are multiple ways where you can get the data from the different sources such as CSV, Excel, and different data sources. For demo purpose, we will try to get the data from our simple Python object, which is a list of tuples. So once you pass the data and the field's name, it will create the data frame. Here we are just having the data in the variable name called df, data frame. Once you have the data frame, then you can use the method called dataframe.show. It will show the high level data. Basically, it will not show all the data if you have multiple data. It will show maximum 20 at the top. Here you can see the data has been shown in the table, ID, name, and marks. Now, if you want to see the schema, because in the previous discussion, we have discussed that unlike RDD, your data frames will have the schema. So based on the data that you have provided, it will create its own schema. For example, here ID is long, name is string, and marks are again long. From the data frame, we can select multiple columns by comma separated. Here you can see data frame.select and marks.show. Show is the method where it will show the data after doing all the transformations. So here you can see you are selecting only marks, then the final output will be only marks. Whereas in second line, you will show the names, comma marks. So it will show both names and marks. Now, let's say you want to get the data, but you want to apply some filter. In that case, you can mention dataframe.filter, and whichever the column you want to access, you can use the dot operator. For example, in data frame, I want to get the marks and I want to get the data where marks is greater than 80. So the simple condition, DataFrame.filter, then you will apply the logic where DataFrame.marks is greater than 80. After applying this filter, you will use the .show method. If some of you are from the SQL background, you can use alternatively where DataFrame.where, and you can use the where condition like DataFrame.name is equal to alias, and again show method. So it will show only that record. Now we will be getting into the other submodule in the PySpark, PySpark.sql.functions. In that, I'm going to import the call. Call stands for column. Now I'm going to create a new column by applying some method. For example, I want to create the new column with name ID2. Then the logic for creating ID2 is whatever the value in ID, that value will be multiplied by 2. Here you can use the column method call and the field name for that. In our case, ID is the field name, so that's why we are using the ID. Then after applying this logic, you can see at the end, there was a field created with the name ID2, and this field will be having the values, which is the multiple of the ID value. Now let's say you want to remove some column. DataFrame.drop, then you will be mentioning the field that you want to remove. Since we created ID2 for a simple demo purpose, we are removing the same. Now after removing, you don't see the ID2. Now let's say you want to rename some field name. So again, the name also very explicit. DataFrame dot with column renamed. The actual name that you have now and the name that you want to rename. Here name is the existing one and student name is the new one. After making this change, your data frame will be replaced with the new field name, ID, student name, and marks. In the same way, from the PySpark.sql.functions, we have multiple other aggregate functions, such as count, average, max. Count and average are okay, whereas max, even in Python, we have the inbuilt function called max. To avoid the confusion, I'm giving the alias as underscore max from the PySpark. So after applying this DataFrame.aggregate, then I'm applying the count. That means that I'm getting all the records. Once I get the count of that, I don't want to mention as it is. I want to give the alias name for that field, total rows. Same goes with average, the average of marks, and I'm giving the alias name as average marks, and so on for the max. So once we have this, when we execute this, you will get the total rows, average marks, and maximum marks. Now let's say sometime you want to sort the data frame based on some field. Obviously, when you sort it, most of the time it can be a numeric values. So in that case, I am just mentioning data frame dot order by. Then the column I am choosing is data frame dot marks, so that the marks will be sorted and the table will be displayed based on that. By default, marks will be sorted ascending order. But if you want descending order, explicitly you will mention data frame dot marks dot descending, so that you will have the sorting order in descending way from higher to lower. Same way, like databases, you can use the distinct, so that you will have unique rows. Since we have already all are unique, so you may not see this duplicates removed because there are no duplicates. And also we can use the join and union, same like database. So that's why we discussed when you use the data frames, it's almost like a SQL operations. Now let's create a simple two data frames, data frame 1 and data frame 2, whereas one has Alice and Bob, another one has Bob and Charlie. Now you can see among these two data frames, Bob is common across two data frames. Now if I do the inner join, basically data frame 1 dot join the other data set based on ID. So wherever ID is matching, that will be taken in the output. Then the type of join I make is inner join, same like SQL. Then output will be Bob only because ID, which is 2. Same goes with union operation. So now it will attach both the data frames together. So it will be very useful. When you want to concatenate two data frames, you can use the union, provided you will have the columns names are matching. Now coming to the describe and summary. As soon as you get some data set, you want to see how the data looks like. What are the statistical values such as count, mean, standard deviation mainly for the data spread. and also minimum value, maximum value, so that you will have the overall idea about your data set. So that's what you will use the DataFrame.describe.show. It will show the count, mean, standard deviation, min and max. So if you want something to be excluded, then you can use the select method, like how I used in the summary. Even in describe method, you can use DataFrame.select and you will use only the marks, then you can start using the describe. The same thing we can try in the summary. Describe and summary almost same, whereas in summary you will have the percentile value also. For example, 25 percentile, 50 percentile, and 75 percentile. And here you can see we have chosen only marks because after selecting the summary, we are using the select method. The same way you can try for the DataFrame.describe, then you can use the select method if you don't want the ID in name. Now, if you want to create the temporary view like a SQL database, then you can use DataFrame.createOrReplaceTempView or TempView. Here I am creating that view in the name of people. Now after that, you can directly use the spark.sql. Then you can start using like a table, select star from people where marks is greater than 90. If you want to apply so many SQL operations, as soon as you get the data frame, you can create a temporary view and start using all your SQL queries so that you don't need to have so many methods in middle. You can directly use the SQL queries like spark.sql and in your SQL query. Here you can see I applied some condition on the people temporary view. Then I got the results in the same format, ID, name, and marks, where marks are greater than 90. In reality, most of the times you will be using the data frames rather RDD. However, we have understood the reason also why we were using the RDD when we have the unstructured data, and we have seen the possibilities and the benefits of data frame, and also we have seen some of the basic methods in data frames. And this is all about this video, and always be a rainbow in others cloud.